How's it going, everyone? Welcome. Euler. That's right. So, I'm going to explore the Typescript course taught by Matt Pollock, a software engineer that previously worked at Versal, right? So, the whole point of getting myself into the TypeScript is first, I need to understand what this thing is, and the need comes because I have a problem. And the problem is that I don't know what is this, and especially since I am offering my services to several companies, all right? And because they need to, for me, develop applications, whether it's SaaS, back office apps, websites that need to be ranked by the search engines, so on and so forth. So they using now a lot of these technologies that are on the web industry, and that has matured over the years, of course, thanks to the efforts of a lot of engineers in most of these top tech companies. So one of them is Microsoft in this case with TypeScript, and also is a TC39, and there's a lot of drama on that, especially for with polyfills, something that is very interesting to take a look at that, and how now the line between the technical and scientific adventure feeling collide with the political decisions that are made by those who are pay you most of the time. So in any case, there is a heated debate on the things this idea around the polyfill, which is pretty simple, is how can we now as developers guarantee that new features in JavaScript are accessible across different browsers, right? And not I'm not talking about is syntax here, which is something that is provided, but I'm talking about is common operation or common behaviors that the language expose to us, so we can make our job a little bit more simple, right? So a good example is how can we use now is promise.finally back in 2019, which is a specific behavior of of how as a programmer we deal with a with single eventual values, all right, using now promise, aka, so how do you now is uh, get that information from this source, that it might some sort of server, a database, or another API, you name it. So we need to wait for that servers to go, but that give us some data, all right? For example, let's say you're building now a fintech app, all right? And you want to now know is that particular user and the set of transactions, because the user wants to know that at least is the last 7 days, right? So you need to request the data from the server, pull that, especially from the user, and then from the transactions database. So all of these databases might live in different server, and you have to wait for those servers to process that query uh, and get back that data. So once you now have all of this piece of information in a change of computations, right? Then you want to apply now some final operations, some final statements here. So this is what the finally, at the end of the day, using now promise allows you to do. Okay, so uh, again, there is a heated debate on polyfills using now core.js, and again, something that is quite interesting to dive deep. But what is relevant in this video is at least looking at the build process, all right, and then the essential types and notations as we move into the docs, reading in the docs, understanding what the TypeScript is, the history of that, and how do we get here, and what are the things that we need to know and use in order to make those applications, or in order to write these TypeScript applications. Where the goal of this is, well, as your application grows in complexity and files and features that need to provide and the team size, well, you need to also is make that in a way that is easy to understand. Okay, so TypeScript here, with the effort of a lot of engineering back in 2012 in Microsoft, when they were reading programs using C Sharp, it's a static language that you can put all of these type annotations, aka the shape of the data at this particular moment in the programs, so you can see the data flow, which is one. Also, if there is an error in your program, you will know that before that program executed at compile time or build time. And if you want to refactor some sort of your features in your program, you can easily do that, right? So now TypeScript is this superset of JavaScript that allows us to do that. So why is that? Because JavaScript at the end of the day is great for rapid prototyping, but as your application grows, as I mentioned before, things started to be quite messy. And second, because JavaScript is a dynamic language, aka first, it's a weakly typed dynamic language, which is a fancy way to say, hey, we don't know the data, we don't know explicitly the shape of the data at this position in a program, and this program is executed is one line, one by line, right? One after the another. So aka it is at runtime. So that's why I looked first at the JavaScript workflow, which is just write your JavaScript files, and then that is now understood by the browser. And then in the TypeScript workflow, you have now two scenarios. The first is the development. So you write your TypeScript code in a file, and that now is being inspected by the TypeScript server language, which sits between your code and the ID, which is a great stuff. So you can now get real feedback quickly of what things go wrong and what are the potential errors, right? So once you write your program in this development mode, now it is time for you to ship that code to something that the browser can understand. That is in JavaScript. And here the compiler kicks in, and that is going to transform those TypeScript code into a JavaScript code. Because the confusion here is that it is a compiler, technically speaking, to be precise, it is a transpilation that happens, aka, again, it's a fancy way and a fancy word to say, hey, let's go transform is this code from this human-like language into another human-like language. TypeScript to JavaScript, Ruby to Python, you name it. All of these high-level language. Okay, now, in the production, okay, we have is the particularly compiler that, given a set of options, we can specify is which JavaScript code we want to produce or emit. So now it can be understood by the vast majority of browsers. among other configuration. But at the end of the day, it's just to indicate the compiler here. This is the file that I want to get, one. And second, this is the option I want you to run, right? Whether it is to set some sort of constraint to this code that needs to be checked. For example, the interoperability among models, some specific language and framework check. For example, you're using React to build applications, let's check TSX and so on and so forth, among other features, right? And then also specify is the output directory that all of these files will live, which is usually the dist folder, the distribution folder. Now, on that, and as we look at how can we use TypeScript to do so, and because it can be quite annoying anytime that you define is your file and you need to run the compiler again over and over. So we have the watch mode that say, hey, inspect this file or this set of file under this folder for any change, and then produce the new JavaScript code. So this is great. So what it does is the watcher is take now the JavaScript code, all right? So take your TypeScript code and transform that into a specific JavaScript version. So again, we still need to manually refresh our browser, and because we don't want to do that, so we can use now is the Vite, this model bundlers and Webpack, model bundlers and dev server that allows to now is take all of these TypeScript files and using TypeScript behind the scenes, generate the proper JavaScript files for production. So the thing here is, as we look at the watcher and the Vite and how can we configure Vite and what Vite is, all right? So it has two phases as well, because again, it is integrated to this the modern web development. When you first have is the development phase with TypeScript, right? And the production phase that generates now the proper and evergreen JavaScript files for browsers. So because the compiler in watch mode, what it does is to take that files and now flush. So take that files, generate the JavaScript files, and then flush into the index.html with the new JavaScript code. All right, so that's the whole overview of this, and then what I'm looking right now is at what Vite is. And Vite, yeah, as I mentioned before, I know I'm saying a lot of I'm saying this too many times, but just to refresh and remember this very well. So Vite Vite solves these two problems that we have in modern development. Again, remember that the whole point of this is make our applications to whoever we're going to sell our services and whoever company needs to build this kind of web apps to make them scalable and easy to maintain and extend. So TypeScript now serves to this purpose based on all of the heavy works from engineering and Microsoft. And I know I'm taking, again, a long segue, going back here, in is these two scenarios. So first is the code must run in, so we need to set up a dev server, and the vast majority of tools to do this are now written in JavaScript. So therefore they are not they're not taking the full benefit of this multi-core processing. Why? Because JavaScript, in essence, is a single thread language. It doesn't allow you to take the advantage of all of this multi-pros, the multi-thread in your CPU. However, there are different environments that allow you to do that. So for example, service worker. But again, JavaScript in general is follows the web guidelines to be a single thread language. Now, having said that, then I look at this is the this is the dev environment, right? And also you need to guarantee that you use the new latest features of the language from ES6. So, and also you need to provide is this hot model reload. So anytime that a file changes, you need to refresh those chains. You need to reload those chains and refresh the browser, aka to spin up the server again, and then now send the signal to the browser. This is for development. And the other is for production when it comes to bundling stuff. And doing that is extremely complicated. The detail is, to make it simple, is that how you now transform is, or how you handle is CSS and image and SAS files. For those who are not quite familiar, is just a way to make your CSS code much more easy to write. In SVG image, how you make all of these different files accessible in accessible, usable, and package easy to deliver to lower end devices. Because if you have now a high throughput or a high connection, high speed connection, it's not a big deal. But how you can make sure that you serve your content for those low end devices, that at some point you might be in an area that, well, there is no that high speed internet connections. And again, this particular problem is extremely hard, and there are several techniques that trying to solve this. Code splitting, lazy loading, you name it. So because this is bundling, and Vite is not using, unlike in the development, a model bundler called ESBuild that is written in Go, is using now rollup to guarantee a production build. Why they don't go with ESBuild that is written in Go and is much more performant than rollup? It is up to you to figuring out that. I'm not going to dive deep into those details, but the TL is that rollup now provides a lot of these nice features that programmers need when they generate production build. ESBuild, despite that it's fast, is not meant to produce this production builds for applications. Yes, for library, but not so far for applications. And we have now different model bundlers out there in the wild that is aiming to now is based on Rust or Go, particularly in Rust, to now speed up the web production, the production of to speed up the development, tests, and production checks. So that's great. That's cool. Absolutely. That's pretty neat, by the way. And yeah. Okay, so you got it. Blah blah blah. And finally, we are looking at this: how you compare now Vite with Typescript. So it turns out that since Vite is now this model bundlers, and you may think of this like the modern web front-end tooling, which is a fancy way to say, hey, this is a framework that provides you now these two scenarios, the development and the production. Okay. So Vite with TypeScript, when you're trying to run TypeScript in a Vite config files, usually it doesn't emit any files. And the thing here is that it's because it enabled that configuration Vite by default, because it is up to the Vite that is going to call this TypeScript file, or this. So Vite is going to call your TypeScript compiler functions for you based on the TypeScript configuration on the Vite. Why is this? Because now Vite is taking control over that. This kind of intermediaries, right? That call your function, which is something that you can see a lot in React applications or in any framework. The more experience you have, the more you're starting to see this pattern, right? It's like React actually is now calling certain functions for you to hook into this. For example, with hooks, what you have is use a state, use ref. So anytime that you want to React to keep track of a piece of information, you use now use state. If you need to keep an information and now re-render that piece of UI, so you use that function. Or if you want to store some piece of information, you can use this and use ref, usually a DOM element. Or if you need to run some sort of optimizations, aka to prevent re-rendering, so you use Mimo and use callback. If you need to somehow store some information globally in your application and let React do that for you, you go with use ID, and so on and so forth, with all of these different hooks that React provide. But again, you just use those functions that the framework provide to do something about it, right? Which is exactly what happened here with Vite. So we have TypeScript configuration, so we have the TypeScript compiler installed, but this Vite is going to call those functions when they see fit, all right? So this is the distinction between the Vite and VSC, and anytime that you have now a framework, which is something that Martin Fowler mentioned, and he have a lot of time more in this industry. He say, hey, a library is when you call your functions directly. So a good example of that is when you, for example, is now create a new array with this. So when you create a new array with a fixed length. Let's say it's going to create an array with all of this with a 6-slot array, a 2-dimensional 6-slot array. All of that pre-filled with zeros. Okay, so array dot array. So you define is the dimension. You say 6-slot. All right. I do want to fill each one of them with zeros. All right, but I also want for each one of those positions fill that out with this 2-dimensional array. So in that case, you can say, hey, this is the length, and then for each one of them, I want to now is create again a 6-dimension. Okay, now an array of 6 elements here, and then fill this with zeros, right? So if you hit here, you see now we already create is this two-dimensional array. That's pretty interesting. That's pretty cool. And the point here is this is how you can now create is this is calling your functions directly. Why is this? Because this is the native API, so there is no other things that is being calling for you. This is something that the language come up with this. But when applications or when frameworks call functions natively for you, or they're doing something that is not supported by the language, we call that as inversion of control, aka it's not your frameworks calling your functions. So why this is important? Well, because this is exactly this particular patterns that happens across frameworks, and Vite is one of them. React is another one, right? And anytime that you hear this framework word, so you now see that, hey, the framework is actually exposing is certain functions, and they calling that for us. So environments as well is something is another, depend of the environment, is another layer of abstraction similar to frameworks. But in any case, all right, let's see what is the solution in this video.
So the reason that when we run TSC we're not emitting any JavaScript files is thanks to no emit true. Disable emitting file from a compilation. I guess should be emitting files from a compilation. So why would we want to do this? Well, if we turn this off and we basically say, okay, in TypeScript as a linter, we're going to say run TSC, then inside here, first of all, it's going to say, okay, right, we've got some interesting stuff going on, probably need to disable this config option, set up counter.ts, okay, got some various other errors, and we're producing some JavaScript too. This is essentially just doing the same work twice. Because what we're doing is inside Vite, Vite is now the one handling the actual bundling, the actual turning this TypeScript code into JavaScript code, right? And so no emit true basically says to the TypeScript CLI, we don't need you anymore, or rather, we don't need you to produce JavaScript files anymore. Exactly. So if I remove...
So this is pretty basically telling, at least with this option, is telling that. I already, this is the solution, I'll put it here.
These files here, because they're definitely not needed anymore, close down some stuff. The discussion is then, why would you need no emit true? Or why actually do you need the TypeScript CLI at all? Well, Vite itself doesn't actually do any type checking for you. So when we're working in Vite, we can basically do anything we want in terms of TypeScript. We can just, remove stuff here and remove HTML button elements as well, just like give us TypeScript errors all over the place. Vite won't mind. Vite will continue running your dev server. It will push code to production if you want to. And so these actual errors here, Vite doesn't know about these. It just uses something called ESBuild, which is an alternative to the TypeScript CLI, to take this TypeScript code and turn it into JavaScript code without type checking. This means that it's faster at doing that job than the TypeScript CLI, because the TypeScript CLI has to type check your code and then transform it into JavaScript. Whereas the Vite CLI just transforms it into JavaScript, which is a lot easier. So, why do we need TypeScript CLI? In order to type check our project. This means that when we run TSC or TSC watch inside here, and we, for instance, make a change to here to count, we're going to get an error inside here, and this is basically like just a warning to us. It's not going to block production code if we don't want it to, but it's just going to say to us, you have something wrong with your code that you might need to go and fix. So TypeScript here is acting more like a linter than an actual build process here.
Exactly. The thing here is exactly TS compiler here is acting more like a linter than a compiler. So pretty much like the JavaScript engine that behaves like a compiler for analyzing your code, not generating an output. When you use it, this is true. This is true when you use TSC as a compile or TSC with Vite. All right. So TSC is acting, or TSC TSC is only checking your project. Exactly. TSC is only type checking your project, and Vite is checking two. Exactly. In Vite is checking two scenarios in your two scenarios in the web development Exactly. In Vite is providing tools for two scenarios in web development. Exactly, two scenarios in the web development, for develop and production. So if I ask now Gemini about it, right, and say is this, it is safe to say that, yeah, it is. Exactly. So TypeScript is only type checking your project, and Vite is providing tools for two scenarios in web development: the development and the production, right? Which is the dev server and the help model reload is using now ES-build, which is written in Go, and the scenario B is the production, which is the optimized code, right? Which is bundling and optimizations. Since browser doesn't support native ESM efficiently for thousands of files due to network overheat, that's where you have. So again, this is something that is extremely hard, but it is what it is. TL didn't read. Too long didn't read is this, right? You can put it here. There you go. But it's summarized in this.
And this is how you're probably going to be using it in most of your, especially front-end applications. Sometimes when you're working in Node or working in other places, you're going to need to use TypeScript CLI yourself in order to turn your TypeScript code into JavaScript code manually. But in many applications, that's just not going to cut it in terms of the complexity needed. So if you use Vite, if you use Next, Remix, Astro, any of these big front-end frameworks, then you're probably going to be using TypeScript more as a linter, and you're going to have inside your TS config no emit set to true. Now, this means that TypeScript still has an important place in the build process. It says whether you're over your entire repo, whether everything is type safe and whether everything is doing what you expect it to. But it's not actually building your code. Really important difference.
TypeScript in the CI/CD
Let's look at a
system.
place where TypeScript really shines, which is on a CI/CD system. A CI/CD system is basically a server that you can contact and push your code up. And what it will do is it will run various checks, do various things on your code. An example of that is GitHub Actions here. So inside this explainer folder here, I have a GitHub file or folder. Inside there, I have a workflows folder. And inside there, I have a ci.yaml file, or YAML. And what this does here is basically we give it a name of CI. And when we push our code up to GitHub, this is going to tell GitHub to run some stuff, or run some commands, do some stuff to our code. And basically, if those commands that we're running fail, then we get a big cross on our commit or our PR or something like that. Whereas if everything succeeds, then we get a nice little check mark. This can
A big cross. Okay. Yeah, let me take some notes out of this. Yeah, you do want to take some notes out of this.
place where TypeScript.
So this is TypeScript in the CI/CD process. So TypeScript in the CI/CD. TypeScript in a CI/CD system. Right, take it. There you go. Dig it.
TypeScript really shines, which is on a CI/CD system.
So TypeScript.
A CI/CD system is basically
Why not?
a server. Let's look at a place where TypeScript really shines.
Okay. This is where TypeScript really shine in a CI/CD system. Not only TypeScript, but also the any checking any checking you want to run against your code. So testing, building, transpiling, so on and so forth.
Which is on a CI/CD system. A CI/CD system is basically a server that you can contact and push your code up. And what it will do is it will run various checks, do various things on your code. An example of that is GitHub Actions here. So inside this explainer folder here, I have a GitHub file or folder. Inside there, I have a workflows folder. And inside there, I have a ci.yaml file, or YAML. And what...
So, yeah, we're exploring here is this. In this YAML file here.
GitHub is basically we give it.
And then you get is this. Okay. Okay.
Give it a name of CI. And when we push our code up to GitHub, this is going to tell GitHub to run some stuff.
Okay. So when we push our code to GitHub, this file, this YAML file tells GitHub to run some code when as when certain events happens. In this case, when we push code to any branch, right? When we push code to any branch, and second is when we make a pull request. When we push code to any branch, and the other is when we make a pull request, right? That's interesting why they call pull and not push, because at the end of the day you are trying to merge this, but it's like pull request is okay.
Run some commands, do some stuff to our code. And basically, if those commands that we're running fail, then we get a big cross on our commit or our...
Exactly. Is those commands if any of those commands fail, we get a big cross. Otherwise, we get a green mark.
PR or something like that. Whereas if everything succeeds, then we get a nice little check mark. This can be really useful when you're running against, first of all, running against all pushes. So we're pushing, like whenever we push code up here, it's going to just check to make sure that everything's okay. And it's also going to run against all pull requests as well. Really, really nice. This means that you can check before you merge something whether that code is going to be okay. Now, let's just run through all the things that this would do. This would run on a like a server on GitHub, which is running the latest version of Ubuntu. Then we check out the repo with Git. We set up PNPM because this is a PNPM repo. Then it also like a server check before you merge something whether that code is going to be okay. Now, let's just run through all the things that this would do. This would run on a like a server on GitHub, which is running the latest version of Ubuntu. Then we check out the repo with Git. We set up PNPM because this is a PNPM repo. Then it also sets up Node with PNPM's cache too. Then we install all the packages using PNPM install, and then run PNPM run CI. Let's take a look at that.
So here we're saying is so essentially I am telling to the GitHub servers to one set up exactly. I'm telling to GitHub servers to one pull the repo. Okay, now exactly runs on Ubuntu latest version. Okay, all right. So my app, I'm telling to GitHub servers that my app needs to run on Ubuntu latest server. Exactly. So hey, I do want you to run in the Ubuntu latest servers. After that, pull the repo into the OS. All right. Install now the dependency. Install now the dependencies for my app, in this case, Node, all right, use PNP version. So install the dependency for my, in this case, Node, and exactly. So in this case, PNP and Node. That's interesting why they put that in that order. Okay. Set the version of PNPN to 7, and for Node to 16.x. I don't think this is gonna run because that's too old. And then now install, and then now run this. Exactly. And then install the dependency for my environment. Install the dependency that my environment need to run my app, and then install the depths that my apps needs to run, and that is, well, with the PNP install frozen log file, and then PNP run CI, which is a clean install and run. Okay, so install my depths with that specific version, that specific graph depth version. And then is this, right? And this particular process is the same for any application written in any other environment or in any other programming languages, right? But the process is the same. Hey, I need to set up where I'm going to run this, in which OS I'm going to run this. Then is what are the dependencies that I need to install for this environment or this language or framework that I'm going to use. And then what are the dependencies my application needs to. And then runs the code as it is. Let me put it in this way. I prefer to put it this. What if I say this? And do this, right? But this specific process, this is the pattern here. When you're using now a CI/CD server, in any case, whether it's in GitHub or AWS or Azure, you name it, right?
Inside our package.json, we're just running the CI script here. And the CI script currently just runs TSC. Now, this means that if we run pnpm run CI, let's just cd into it, 016, now we can get information as to whether our process
What the hell is this?
and run CI. Let's just cd into it, 016. Now we can get information as to whether our basically our process is working here. I think I actually need to install this directory first, then I can run pm run CI, and now you can see that TypeScript ran, found no issues, and just exited the process without causing an error. If I were to manually add an error, then I'd be able to see, let's just say, can I remove this, cause an error? No. I'm not sure what I can do. Here we go. Just do something like this. pm run CI. It's going to catch this issue, which is going to error at runtime before I even ship my code to production, before I even merge it into my branch. So using something like GitHub Actions, there are many, many alternatives like Circle CI, hundreds of alternatives.
Exactly. There's a lot of company that builds on top of this problem. Right.
Alternatives really that let you.
So Circle CI, right? Circle CI. What is the competition of this? Circle CI tutorial for beginners. Circle CI continuous integration services. Competitors, right? According to you, you have Jenkins, GitLab, CI, GitHub Actions, AWS Copilot, and Deftron. Okie dokie. Okay. Deftron, the AI for DevOps Kubernetes platform in United. Well, the real cause of Kubernetes operational chaos. Key 8 multi-cluster here. So this is for their seamless integrations. You can name it, right? So what it is just a layer that connects to all of this. Rising Star Partner of the Year, technology. They also have as part of the compliance policies. Most innovative DevOps vendors. I don't know who actually gave it to you. Cloud native computer and server member. So on and so forth, right? AWS partner, Graviton ready, DevOps software competency, ISV advanced, migration and modernization software, and Google Cloud partner, and all of this. I don't know. Yeah, I don't know. It's like you can come up with all of this batches and stuff that I can design that. I don't even have to design. I can just even generate that. I can tell, hey, Gemini, make this logo, right? Make this logo in an SVG and put it on my website, and he will do that. So it's like, what the French stuff is this? So I'm thinking that they are on India, maybe. Full of Indian guides. I'm laughing because they are desperate for that, man. It's like, what else? Wilmington, Delaware. Exactly. It's like, man, we need to finance operation leads, and there you go. I wish them the best. Honestly, totally, absolutely. Okay. So yeah. Kubernetes for telecoms, in the industry that, of course, so having this set of guardrails in your code before production is something that you want. You have telecommunication, financial service, healthcare, retail, and e-commerce. That is interesting because real estate is another one that you might have there, right? Real estate is another one that you might have or need to have there. All right. Okay. Ship faster, stay online, and sales. So yeah, that's the promise here. Similar for the healthcare. Okay. Kubernetes with other complexity for healthcare, and in the healthcare you need to have a waterfall development. You want is a particular feature doesn't cause any bump in a heart rate device. No, that's a no, bro. That's a no. That's a no. In the fintech as well, in the financial services, CI/CD, unique to fintech. They also have to go with a lot of compliance. There you got it. All right. Okay. Cool. So we get this. Let me actually put it this. So this is part of something that he mentioned, which is the CI/CD process.
Actions. There are many alternatives like Circle C. Merge it into my branch.
So there are several alternatives to GitHub Actions. For example, is GitLab. I am not quite familiar with GitLab. GitLab, according to you. Key competitor identified across multiple sources, including CloudBee, Harness, JFrog, and Travis. Yeah, other notable alternatives are Jenkins. Notable. But this is based on this G2. What is the CloudBee? But again, this is what I will say that DevOps, exactly. DevOps competitors by Gartner. Exactly. Okay. So according to Gartner, you get is this. For willingness to recommend Huawei Code Arts. Holy fuck. Integration and development. Bitrise and Body. Huawei Code Arts. Damn, some Huawei is making it his way, bro. Bitrise review. I have heard about Bitrise. Okay. Its private head office location Budapest, Hungary. The CI/CD platform built for mobile and DevOps. A business partner, one that has comprehensive understanding of the mobile space and can help us move ahead. Bitrise stood out as obvious choice to us. Fully host mobile DevOps platform, test, deploy, release, optimize, and develop. Tag Hubert, TripAdvisor, Shopify, Equinox, Grindr, and GoDaddy. Oh, okay. Customize Bitrise to fit your needs. Best in class build speed. Automated code signaling. But again, this is for building. Exactly. DevOps for. DevOps for DevOps for that, right? DevOps for mobile application, mobile development. But it's a platform for mobile DevOps. Okay, so thanks, Gardner. Absolutely. Okay, let me stand up. Okay, thanks, Gardner. I'll be right back. Mm-hmm. All right. Okay. Hired rated by your peers. Deftron. They don't mention anything about code pipeline stuff like that in the IT services or in the banking. Mm-hmm. Ansible automation platform. And Octopus deploy and so on and so forth. Azure DevOps here. Cloud-based platform, Urban Code Deploy. AWS Cloud Formation. Mm-hmm. AWS Code Pipeline. Azure's Pipeline, Bitrise. Mm-hmm. So you get the idea, right? All of this. All right. Is that we get is GitLab, Jenkins, of course. So Jenkins, GitLab, Jenkins, Bitrise. Mm-hmm. GitLab, Jenkins, Bitrise, AWS, Cloud Formation. Mm-hmm. AWS Code Pipeline. No, Cloud Formation, exactly. AWS Cloud Pipeline, which is another service that they have. CloudBees, JFrogs, Travis. That's interesting that they don't mention is CloudBees. Mm-hmm. Oh, I get it. So you get CloudBees, GitLab, Jenkins, Bitrise, AWS Cloud Pipeline, so on and so forth, right? You get several of them. So Gartner, 2025. There you go. And here is this. Ooh, God damn it, don't tell me. Fuck that. Alright. Okay, good.
Let's look at a place where TypeScript really shines.
Okay, we were
It's
here.
just before you deploy to make sure it catches that too. So this is where TypeScript really shines as basically a guardian angel, watching over your code, making sure there are no issues with it whatsoever before you push it up, or it kind of lets you catch a lot more issues really before you can even see them in production. Airbnb did this when they kind of migrated over to TypeScript, and they found a massive reduction in the amount of errors that they were seeing pushed to production because they were being caught by their CI much earlier. Really, really cool, and it's an amazing use case for using TypeScript.
Again, for applications, because Airbnb, the use case he's talking is Airbnb now go from one prototype to a massive application, right?
Either as a build tool, because it's going to catch type errors there, or as a linter, as we're doing here.
Should you type, wait, what? Oh, it's this one.
One really interesting topic, which is relatively controversial between different dev teams.
Should TypeScript block your dev server? Okay. So should TypeScript block your dev server? That's a good question. That's a very good question.
Is should you block your dev server when you have TypeScript errors? Should you block your dev process, prevent you from moving forward when you have TypeScript errors? Let's say you have an error here, which is saying type number is not assignable to type string. We're saying that this number should be a string, but in fact we're passing a number. Not good. So should you, when you go over to your dev server here, actually should it block you from doing anything until you fix those errors? Now, I have this set up. So I have it set up inside my vite.config.js inside here. I've added Vite plugin checker, and it's basically inside checker, I'm passing in TypeScript true, and with this setup, it means that when I run this, first of all, I get errors in my CLI down here, so it's actually going to do the type checking for me, and it's also going to run it inside my dev server too. Now, some people like this approach because it means that they're forced to fix their TypeScript errors before they actually see them on the screen. This means that when you then push them up to your CI, which is also checking your TSC, you're not going to get any surprises because you've known about them all the way from your dev server. But I really don't like this, and I never ever set up my TypeScript setup this way. TypeScript really is just you should think of it like a linter. Unlike other strongly typed languages, TypeScript just compiles down to JavaScript. It's not I don't know, like Rust or something, where it's really important that you get all the types right because those types feed into the runtime. TypeScript types disappear at runtime, as we've seen. When they get turned into JavaScript files, it's just pure JavaScript. So TypeScript is really just some annotations on top of JavaScript. And so if you've come from those strongly typed languages, you might think, oh, I need to fix my types first. Of course I do, because then it won't work at runtime. Whereas actually TypeScript, of course it'll work at runtime. So what I like to do is really, if I encounter this setup, I'm really just sort of losing information here. Sometimes you actually just want to run your code in a broken state just to see how things are working and then fix the types afterwards, sort of in this prototype stage when you're just kind of working through your setup. And so this whole feeling of blocking my tests from running or blocking my dev server from running when I'm doing this, it feels awful to me because really the runtime and the types are two separate things in TypeScript, and you should treat them that way. The types just tell you things about the runtime, sure, but the runtime never ever uses the types. A different setup that I prefer is if I cd into this other directory, number 3, then I can see that I can say npm run dev, and I think I need to install. Now, inside this setup, I have something different going on. I can go into the package.json here, and it's going to show me something important. Now, what I have is I have dev and this is go into this. I need to install. Now, inside this setup, I have something different going on. I can go.
Exactly. So let me see how you can actually navigate across. Because it's not here. You're not navigating through files here. You know? It actually is. Exactly. You're not navigating files through here. That's interesting.
Into this.
Exactly. It's like how you can navigate through this, bro. Exactly. The vacuum navigation feature in VS Code. This allows you to navigate through your project folder and files or jump to specific functions and variables within a file without using your mouse. It is keyboard shortcut is focus and open drop down, command shift point, opens and focus the drop down. Holy fuck. Okay, so if you are here, for example, let's say, hey, I'm doing here, and then I want to go to the editor, right? Okay, good. I want to shift to the editor, command sheet this. Oh, that's pornographic. Oh, that's pornographic. This is how you can navigate through breadcrumb. Delicious. Oh my god. Open without focus without opening. Focus without opening. Oh, okay. Focus without opening. Oh shit. Oh crap. Okay. Focus without opening. And then you do this. Oh crap. Oh my god. Okay. Jesus. French, those guys. That's quite interesting. Okay.
The package.json here, and it's going to show me something important. Now, what I have is I have dev, and this is running run p dev colon asterisk. What this is going to do is using npm run all, it's going to run all of the scripts inside this package.json that start with dev, and it's going to run them all at once. So here I have it, it's running Vite, first of all, great. And it's also running tsc watch. Now this is different from my previous setup because what I've got now is on this side, I get 0 type errors inside my dev server, it's not blocking me at all. Whereas when I go to my terminal, I can now see the type errors just in my terminal. So I get a really nice readout as to what TypeScript is thinking about my code that I'm pushing, but I can also see everything that I'm working on at runtime working here. So this is my recommended setup, where you should be able to always access your runtime code and see how the JavaScript is working, but you should also always have the ability to just check in with your TypeScript and make sure that you've not made any stupid mistakes. But one should not block the other just when you're working on it in dev mode. When you go up to production, sure, TypeScript definitely should block you at that point, and you should have some blockades to make sure you can't push broken code to production. But you should be able to mess about with code that TypeScript thinks is broken in dev. Often when you're working in a front-end app or a back-end app too, you're going to want to run just some quick scripts every now and again. These scripts could be absolutely anything, and sometimes you don't want to write them in Bash. Sometimes you want to write them in, let's say, TypeScript. So we have a script here called do something, and this script, what it does, just says console log, the script is working. Then it takes in any arguments that you pass it from process.argv, and then it just console logs those args. So
to run.
I have set this up with something called TSX. And TSX, as you can see, is a dev dependency here. What TSX does is it runs basically ESBuild on the TypeScript files, and that bundles them into JavaScript. Then it will just run those JavaScript files. And it does this extremely fast, and it doesn't do any type checking, crucially too. So TSX is a really great way to just quickly run a TypeScript file if you just need a script to do something. So inside this directory, I can say npm run do -something, and I can pass it some arguments if I want to. So I'll say A, B, and C, like this. And now, as you can see, it ran TSX, sorry, on scripts do something.ts, passing it A, B, and C, and then it said the script is working, and I got my arguments back here, so A, B, and C. This is great for if you just want to, I don't know, run a database migration or just run some local stuff, and you have access to all of the things that Node can do inside here too. So we have it just inside scripts.ts, do something.
Exactly, receive these arguments here and then
TS. It's a really, really nice system for just quickly running a script locally using TypeScript.
Okay, couple stuff here. Okay, couple stuff here. Oh shit. Well, that'll be all for this video. Oh, you don't see it? Okay, what? Okay. Well, that'll be all for this video. Take care. Bye-bye.